the received data at the base station, and we send the offset values to the road. So what we get, did you basically understand the intention of having a GPS receiver at the known location? We know the location of the base station, and we know the coordinates that are currently being read by the GPS receiver. So we should be able to calculate the distortion between these two coordinates. And we apply this distortion to the robot. Yes.
But if the field is big, the distortion can be dynamic too, because of the weather cloud.
Yes. According to the research done on this RTK GPS system, the base station and rover can be as apart as 8 kilometers. So distortion will not be significantly different within 8 kilometer radius. Okay. So surprisingly, when we have built this RTK GPS system, we were able to actually see accuracies up to 5 centimeters. If I have a GPS receiver in my hand, if I move it by 5 centimeters, I could see the change on the system. If we can, I can show you one of the plots of this RTK GPS. This is the plot of the rover antenna attached to my roof of the car, and I just went around a circular path. You can see the scale here, 50 centimeters, and you can see the starting point and ending point exactly coincides. This gives us the idea about the accuracy of the RTK GPS system. Next slide, please. Okay, coming to the plant detection. How do you think we can detect a plant out in the field? We are actually using a 3D camera that is LiDAR. LiDAR stands for light detection and ranging. So we are using this particular LiDAR to detect a particular plant. When this particular LiDAR looks down at plants, it generates point clouds like this, and running different algorithms, we will be able to separate the ground plane from the plants, and we will be able to say that there is a plant over there. And then once we detect a plant, we just determine the local coordinates of the robot, and we store these particular coordinates in our database, saying that I have seen a plant at this particular location, and I store these coordinates. And tomorrow when I come to the same location, I know that this is a plant I've seen yesterday. And that's how I store the data in the database. Yeah. And not only not only depend on RTK GPS, but also odometers on the board and inertial navigation system. Fusing all these sensors, we should be able to get position accuracies less than 3 centimeters. And this is our test field out on the 4th Street and Baker Avenue. This is Texas Tech Cotton Research field. As you can see, I'm not sure if you're able to see it, but this is the GPS antenna for the base station. And actually got this little LiDAR for you to demonstrate. We have imported this sensor from Japan a month ago. As you can see, this gives us 3D information. As I get my hand closer, color gets darker.
Talk about the black and white, that's probably easier to understand.
The black and white image is basically intensity of the reflected backlight. So this particular RGB image is depth image. See. So it basically has a single detector in it. That particular detector keeps scanning throughout its resolution to get ranging and intensity data for individual point in its resolution.
So it's something like Kinect?
Yes,
Ah.
it is something like Kinect.
Something like that, but not exactly the way Kinect works. Kinect, they use stereo imaging to get depth information, but this has a laser being transmitted, and it actually calculates the time of flight. When it hits the object, it calculates the time of flight, and that's how it knows the distance from the obstacle. And I think that's it. I'll be more than happy to answer any of your questions.
So what have you done really, other than putting these devices together? What have you done in your work?
We have been working on the
Me
light.
or you? You.
Yeah.
I'm asking you, your
Yeah.
part. You said you concentrate on navigation.
Yes.
What have you done really?
I've been reading
You're
characteristics.
just starting?
Yeah.
Okay.
I'm just getting started.
All right.
Seriously, don't sell yourself short. You had to create that RTK GPS, right?
Yeah.
You guys did.
Yeah, we have assembled the RTK GPS, and the particular plot I've shown you, that was tested by us.
So let me ask you, what is more challenging between detecting plant and recognizing plant?
Recognize. First of all, we should be able to detect, say, if you come across a rock in the field, you should be able to say that's not a plant, that's a rock. That's
I'm not asking what it meant. I'm asking which is harder.
which is harder.
Yes.
Listen
Listen to my question.
I'm sorry.
Come on.
Detecting and recognition.
Or you can say you don't know.
Detecting is a
I don't
difficult
know.
task.
I'm just asking.
Yeah. Compared to recognition, detection is difficult. Once you detect something, all that you got to do is get the local coordinates of the robot and send it to the database. So you should be
But
able to.
detecting could be hard if you are in a garden full of different kinds of plants.
Yes.
Because they're all plants.
That's a challenge, really a challenging task. And we should be able to distinguish between what is a weed and what is a plant as well.
So when you said high throughput,
Yeah.
what do you actually mean? How do you measure that?
I mean, what we mean by high throughput phenotyping is we basically want to automate the process of phenotyping.
But then you have to have ways to measure it, right?
Yes.
So what is your throughput?
Throughput by, I mean, we should be able to do more work in a given amount of time.
So how fast is your robot?
Uh,
Walk.
What's
What's the speed?
the speed of the robot is somewhere around 8 miles per hour as of now.
So
But I
when
don't
you
think
said
it will
state
be-
of the art, can you tell me the state of the art of the throughput in terms of number? Quantify the throughput of the state of the art? Say how many plants per what time, right? Or per acres or whatever, right?
Yeah.
So what's the state of the art?
Currently, I
Do you
haven't
know?
looked into that figure. I can let you know.
Okay, because you're going to claim you're going to do better,
Yeah.
so you have to have that number.
Yeah. That's definitely the figure we should have it.
You should also say that it's highly complex function of what plant,
And you know,
Yes.
it
density,
again depends
what
on the
fuel.
kinds
Yes,
of measurements
I
you
agree
want
with
to
that.
obtain from the plant as well. It's kind of subjective.
So how long you really to stop it from the plant?
That again depends on the data you want to collect from the plant. Say sometimes if you say you just want to scan the height of the plant, you don't necessarily have to stop too long. But sometimes when you want to look at whether there is a flower on the plant or not, it takes a significant amount of time.
counting the number and the size of the boll on the plants,
Yeah.
right? Cotton bolls.
And if
Even
you
for a
ask
human,
it
it's
to-
very difficult.
And if you ask you to count how many flowers does it have, you then have to spend more time at a particular plant. So it's completely subjective and depends on our requirement.
I think even humans find it hard to,
Yeah, it is.
recognize what kind of plant. Just look at the leaves of the two kinds. I can't tell.
They look alike.
Sometimes you can't tell. There's no distinct. So this is very complex.
Challenging.
Except if you say you want to contrast with bamboo with banana, then that's very obvious, right? There's some
Yes.
characteristic.
Yeah,
But
typically it is
sometimes
row
it's
upon row of the same plant, and you want to be able to,
Right.
typically in the field, the kind of
Yes.
objective of this project is to be able to do row upon row of the same plant but different phenotypes.
Yes.
So do you know what plant?
We, to begin with, we'll
Cotton.
definitely start working on cotton plants. Because we have been associated with
All
cotton.
you have to
users.
spot is look at the white part of the flowers, right? That's the significance of cotton.
Yeah.
And you
But-
have checked the location of the cotton, like white cotton flowers?
No, the interesting thing to look at for a cotton plant, you know, is what is the when do you see the first cotton flower? After how many days of sowing, you basically see the first cotton flower. And you know, you may also see how many flowers does each plant have. And you may also see the diameter. There are a lot of things to be done. Can be done. Do you have any other questions?
So it can, like, there's like a weed or something growing in its plant?
Yes.
It
It should be able to. That's the current challenge we are thinking of, how to distinguish weed from the plant. You know, basically, you can distinguish with the habit, and you know, depending on the plant pattern as well. Say, if you are researching on cotton plants, we'll have the pattern of the cotton plant stored in our database. So when this particular lidar scans the plant, it compares the scan pattern with the stored pattern in the database. So if it matches with some probability, we say that's a cotton plant. If it doesn't match with the given probability, we say that's a weed, that's not a plant. So we have a pattern of the cotton plant stored in different camps. That's how we compare.
So, are you gonna, do you need to redesign it to use in another field? Like, because cotton, let's say you are designing this one for cotton and you have different characteristics for cotton to distinguish.
Yeah, definitely. If I can go to the slide of the robot picture.
So let's say if you go for a cornfield,
Yeah.
all of these are changed.
Yeah, definitely. Yours is a valid question. We wanted to make our robot kind of robust to different kinds of plants. So